Hi everyone. Here we have a question on matrices. Question 1. Find the 2 by 2 matrix A for which 2A multiplied to this other 2 by 2 matrix gives us this 2 by 2 matrix. And question 2. Find the values of x and y for which this product gives us that column matrix. Straight away we start with the first question. Question 1. In question 1, question 1, we have the matrix 2a multiplied to 3, -1, -1, 1, giving us 5, -2, 1, 2. We are going to need two uh, notions on matrices. The first notion is that if we have a matrix A and we multiply it by its inverse, the inverse matrix of A, we are going to obtain the identity matrix. So if I write 2 here, it simply means the 2 by 2 identity matrix. The next important notion that we're going to use will be the fact that any matrix post-multiplied or pre-multiplied by the identity matrix will just give us the same matrix. So this is what we're going to use to be able to find the matrix A. Straight away, if we look at our question, we want to find the matrix A. It's a 2 by 2 matrix. So if we follow this stuff here, it will be nice if we obtain the inverse of this 2 by 2 matrix so that when we post multiply, post again, pay attention, it means it is like this. Pre, it is like this. When we post multiply by the identity matrix, that means we multiply no. When we post multiply this matrix by her inverse, look at it, post, we're going to obtain the identity matrix so that the next step now will be to post multiply now both sides by that identity matrix, which will not help us to be able to find the matrix A. So what I'm saying is we'll obtain something like this, 2A, after post multiplying both sides by the inverse of this, we're going to have 2AI will give us the matrix that we have here, this matrix. So that from here, remember any matrix multiplied by identity matrix is just the matrix itself. So we'll have 2a to give us that. So that finally at the end of the day, we'll have to divide both sides by 2 to be able to have the matrix A, which will be a half than this other matrix. Okay? So that done. So we will now proceed to find the inverse of this 2 by 2 matrix. We'll call it M. Let us call that matrix M. Now, the first thing to get is the determinant. The determinant of this matrix will be product of elements of the leading diagonal minus product of elements of the alternate diagonal. So this is going to give us 3, negative, negative, minus 1, which is 2. All right? So the determinant of this matrix is 2. Now we get the inverse. The inverse of that matrix is 1 all over its determinant times the adjoint of that matrix. So this is 1 all over 2. What is the adjoint of this matrix? The adjoint is we interchange the elements in the leading diagonal. So 1 goes here, 1 go here, and 3 comes down. And then we multiply the elements of the alternate diagonal with negative sign. That's where we get that. So the inverse of this matrix is a half into this matrix. Now, having gotten this inverse, we are going to use this notion. We are going to post multiply both sides by that inverse. We are going to post multiply both sides by that inverse. So we'll say post multiply both sides by M inverse. So what we have will be 2a 3, -1, -1, 1 multiplied by the inverse. This inverse 1, 1, 1, 3 to be equal to we post multiply this other side by the same inverse. By the same inverse, 1, 1, 1, 3. No, post multiply. Post multiply, it means this one comes first. 5, negative 2, 1, 2, and then this inverse. 1, 1, 1, 3. So we have post multiply both sides by this inverse. Now, to create space, we let us work with let us create this space. All right, let us work here because we need this stuff here. Now, a matrix multiplied by our inverse, a matrix post multiplied by our inverse gives us the identity matrix. This is what we have here. This matrix, this is our inverse, and so there we're going to obtain 2a multiplied to the 2 by 2 identity matrix is 1, 0, 0, 1. It's going to give us now this product. So I can we'll not take this product, we can put it as a half. 5, negative 2, 1, 2 multiplied to 1, 1, 1, 3. This is what we have. Now, this means a half. 5 multiplied to 1 is 5. Negative 2, 2 multiplied to 1, negative 2. 5 multiplied to 1 is 5. Negative 2 multiplied to 3, negative 6. 1 multiplied to 1 is 1. 2 multiplied to 1 is 2. 1 multiplied to 1 is 1. 2 multiplied to 3 is 6. So we have 2a. 1, 0, 0, 1 is equal to a half into 5 minus 2, 3. 5 minus 6 minus 1, 3, 7. Okay? Now, any matrix multiplied to the identity matrix, any matrix multiplied to identity matrix is the same as the matrix itself. So this one just gives us 2a is equal to a half, 3, negative 1, 3, 7. So how do we get a? We divide both sides by 2. Alright? When we divide both sides by 2, we're going to obtain a is equal to a half times a half, 3, negative 1, 3, 7, which is a 1 quarter, 3, negative 1, 3, 7. Alright? This will be the matrix A, which you can still write as 3 quarter, 3 quarter, negative 1 quarter, 7 on 4. This is the matrix A that we obtain for the first question. Okay? Please don't forget to like and share our videos, and leave your worries in our comment section. Any areas you want us to make clarifications on. That's it for question 1. Now let's take the second question. Our second question, we are given this product. And we're asked to find the value of x and y. So all we need to do is to carry out this product. 3x multiplied to x, we have 3x squared. X multiplied to 5, 5x. 3 multiplied to x, 3x. 2 multiplied to 5, 10 is equal to 2y. This means we have this matrix equal to this matrix. It means this entrance, this entry here is equal to this entry. So we have 3x squared plus 5x is equal to 2. And we have this entry equal to this entry. 3x plus 10 is equal to y. So we end up with this system of equations to solve. This one is quadratic and this one is clearly linear. Okay, so let's start with the quadratic, which we call equation 1, equation 2. With the quadratic, we have 3x squared plus 5x. When we take this 2 this way, minus 2 equals 0. We have this quadratic to solve for x. So, what are the factors of the product of 3 and negative 2? 3 negative 2 is negative 6. So what are the factors of negative 6? These are the factors. So we have to look among these elements, 2, 4, 6, 8. There are 8 elements here. 2, we pick out 2 such that their product is negative 6 and their sum is positive 5. That can only be positive 6 and negative 1. Alright, so we're going to replace this positive 5 by positive 6 plus negative 1. So this equation now will be rewritten as 3x squared plus 6 minus 1x minus 2 is equal to 0. Okay, we open this parenthesis, we have 3x squared plus 6x minus x minus 2 is equal to 0. Now, we factorize the first 2 and the second 2. Here we have 3x is common. When we remove it out 3x, we're going to have x plus 2. Alright, let us check. 3x multiplied to x, 3x squared, 3x multiplied to 2, positive 6x. Okay, this factorization is correct. And then here when we bring out negative 1, we're going to obtain x plus 2. Let us check it. Negative 1 multiplied to x, negative 1 multiplied to 2, negative 2. Our factorization process is correct. But we don't stop here. We have x plus 2, x plus 2. So we'll continue. X plus 2 is common, so we'll bring it out. We'll bring out x plus 2. Here we'll have x, 3x minus 1 is equal to 0. Okay? So, product of two expressions giving us 0, it means either this is 0, in which case it means x is equal to negative 2, or this one is 0, in which case x is equal to 1/3. So we have x as negative 2 or x as 1/3. Those are the two values of x. Let us just write them somewhere here. We have x as negative 2, x as 1/3. Those are the two possible values of x. Now, how do we get the corresponding values of y? We have to come and use equation 2 to be able to get the values of y. If we look at equation 2, so using equation 2, our equation 2 is 3x plus 10 equals y. We're going to put the various values of x in turn to get the corresponding values of y. So when x is negative 2, it means y is equal to 3 into negative 2 plus 10, which is negative 6 plus 10, which is 4. So y is 4. And when x is 1/3, it means y is equal to 3 into 1/3 plus 10. So y is equal to 3 here cancels, so have 1 plus 10. So y is equal to 11. Alright? So the two values of x and y are negative 2, 4 for y, negative 2 for x, 4 for y, and 1/3 for x and 11 for y. This therefore brings to the end, the solution of equation 2.